To eliminate the parameter here, we do have here some trig functions, and so we can use some trig identities. First of all, we're going to just solve for those trig functions. So we have secant of t is x over 2, and tangent of t is y over 3. And we have a trig identity that secant squared minus tangent squared is equal to 1. And so, well, we can now replace what we have. So we have x over 2 squared minus y over 3 squared is equal to 1. However, do notice that we have some restrictions placed on our variables. Notice that secant is never between -1 and 1, meaning secant is always greater than 1 or it's less than -1. So that means that x here, x must be greater than 2 or less than -2. Okay, and I guess it can equal. So we have that restriction here. We need to check to see if there would be any reason that that restriction wouldn't hold already. However, notice if you were to try and plug in a value of x that was between -2 and 2, and then plug it in here, well, you divide by 2, you get a number between -1 and 1. You square that, it's going to be, well, less than 1. So there's no way that we'd be able to subtract something and get 1. So actually this restriction is already built in to this equation. So our equation, which I'll go ahead and square that out just so we can see that, already has built into it the restrictions that we have. So there's our Cartesian equation.